Okay, let's take a look. Now we have some alkenes that do have branching. Let's just go right at it, see how that'll look. As usual, highlight the longest continuous chain. There it is. Then I ask myself, is there anything attached? Sure enough, there is. There it is. That's a methyl group. How will I number it? Here's our first possibly confusing example. We've been saying this. We've been saying number closest to the action. Closest to the action. You'll have to decide what's more exciting, what's more action. A methyl group sticking off or an alkene. Alkenes are more exciting. They just are. Alkenes are a higher priority. They're more exciting. They're more interesting. However you'd like to think about it, alkenes are named by numbering closest to the double bond. Closest to the double bond. So here it is. We'll number from the left. This tells us that it's a butene because double bond. 1-butene because the double bond starts at carbon 1. And if that were not there, we would just say 1-butene. But there is a methyl there, so we say what is attached, where is it attached. 3-methyl. What is attached, where is it attached. This compound is 3-methyl, 1-butene. How about this one? Same process. Highlight the longest continuous chain. What is attached? Methyl. I'll number from the end closest to the double bond. That looks like this. And then I can see this is pent. 5 is pent. The double bond starts on carbon 1, and I have a methyl. Methyl is on carbon 4. This is going to look like this. 4-methyl, 1-pentene. 4-methyl, 1-pentene. Next one, again, highlight the longest continuous chain, right there. Identify anything sticking off, branching off. Methyl, another methyl. How should I do the numbering? Let's check. If I number from the right, I get this. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So the double bond starts at carbon 2, or the double bond starts at carbon 1, carbon 2, carbon 3. So we better number from this end, closer to the double bond. This is a carbon. So we would look at it and say, well, that's a pentene. It's a 2-pentene because double bond starts at carbon 2. I have a methyl on carbon 4, and I have another methyl on carbon 4. We know that looks like this. 4,4-dimethyl 2-pentene. Now I'm almost done, but not quite. You know what to look for. As soon as you see this double bond, you say, oh, be on the lookout for cis and trans. Be on the lookout for it. The molecule won't always be drawn in a way that you can determine if it's cis or trans, but you always have to check. And sure enough, I look at this, and again, just like last time, if you want to, I don't know, turn the paper just a little bit sideways so that this is kind of straight across. And then say what's happening on either end. Are both ends going down? Nope. Are they both going up? Nope. We have one going up, one going down. And you know what that is. That's trans. Maybe you can see it without turning the paper. I don't know. That goes down, that goes up. Either way, you can see that it must be trans. So the name of the molecule would be that. Trans, or cis, if it's cis, goes at the very beginning. The beginning of the name. So you don't have to figure it out until the very end. Once you're ready to draw a box around your answer, double check if it is cis or trans, and if you can tell, put that right at the beginning of the name. This would look like this. Trans 4,4-dimethyl 2-pentene. Don't worry about the fact that we put 2 4s. Methyl on 4, another methyl on 4. They each get their own number, own address, we sometimes say. If this is a di, then you need 2 numbers, even if they're the same. If this is a tri, then you need 3 numbers. however many groups, they each need their own number, own address. All right, how about this one? Longest continuous chain right here, 6. Number closest to the double bond, there it is. So this is a 1-hexene with a methyl on carbon 3 and another methyl on carbon 3. This will be named like so, 3,3 dimethyl 1-hexene. That's how you would name that, 3,3 dimethyl 1-hexene. What about when you get a cyclic compound? Those are actually almost the easiest ones, especially because we're not naming cyclic alkenes that are branched. We're naming just plain old alkenes, cyclic alkenes. Count the carbons, 1, 2, 3, 4, 5, 6. The fact that it is cyclic means the name will start with cyclo. 6 carbons is hex. Ene because it's a double bond. That's it. We don't say where is the double bond, because whether we write the molecule like that, or like this, or like maybe, I don't know, that, those are all the same thing. The molecule is just rolling along. We didn't have to break a bond, we just let the molecule roll. So that is cyclohexene. This one, 4 carbons, we would name the same way. Cyclo because it's a ring, bute because it's 4 carbons, ene because of the double bond. Finally, this is one where we're going to recognize it by its common name. The common name of this is benzene. You should know that by its common name. I'm going to say the official name, the IUPAC name. I won't even write it down though, because you don't need to know that. You need to know the common name. This would be 1,3,5 cyclohexatriene. 1,3,5 cyclohexatriene, and it's never referred to as that. It's referred to by its common name, benzene. This will come up often enough for us that we should be familiar with the name and the structure. Benzene. And there you have it, some practice naming alkenes. Give yourself some additional practice until you feel comfortable naming these alkenes, branched and unbranched, cyclic and acyclic.